Welcome back to video lesson 6.7. It's the last one for chapter 6. In it, we are going to be talking about simplifying expressions. You need your purplish note page that you got today, and please fill out your table of contents. We are on page 77. You can title it the topic of simplifying expressions. First thing I have is a very step-by-step situation that will help us understand what we're going to be doing today. From the beginning, when we started order of operations, we were taking a big expression and then using gems to simplify it down into a smaller expression that was a lot simpler than what we started with. So that's why we've been doing those triangles that are pointing down and showing one step at a time. Today, we're going to end with a version of that, but we're going to be dealing with variables. So here I have an expression. This is something that you might see, 2a plus 3b plus 3a. So we can think of A representing apples and B representing bananas. So those are variables, means standing for something. But instead of a number, let's first think about the variables as standing for fruit. So here we have 2 apples and we have 3 bananas and we have 3 more apples. So we have this situation going on. We can see that we can combine the like objects, and we can make this a little bit simpler than having 3 separate terms. We can combine the apples because they are the same thing. So by combining the objects, we can have 5 apples and 3 bananas, and we can show that using a 5 as a coefficient next to the A and a 3 stays with the B. This is another example. The only difference here is that we have constants. So we have 4 apples and we have 2 apples, and then we have a 5 and a 3 just hanging out. So we can collect like terms. That's what we're going to be using, that phrase, like terms. And we're going to be combining what we can. And we can combine the apples, or the A, and we can also combine the constants. We're going to do a little bit of that as well. So you notice that 5 minus 3 is how they got that too. So now let's go to our note page. Right at the top of next to the word simplifying, you can draw that triangle that we've been doing to connect to our work with gems. And we'll start filling this in. Like terms, you heard me use that phrase. That is when we pay attention to the parts of the expression that have the same variable. Notice with our apples example, we combined the A's together. To simplify, you notice from our other example, we ended up adding the coefficients. So that number that was sitting to the left of the variable is what we added. Also, constants you can combine, like you saw in that second example, if there are more than one constant. So let's do a couple of examples. So right over here, we have 2x plus 2x. If I were to draw 2 x's out, that will represent 2x. And then we have another 2x. How many x's do we have altogether? We have 4 x's. We can show that with just the coefficient 4. So what we ended up doing is adding 2 and 2, and we just drag the x down. Over here, we have this 2 and this 6 are constants. We can combine those constants to make it simpler. The 4x we can't do anything with, so we just drag it down, and then instead of having 3 terms, we have 2 terms, which is 4x plus 8. That's what we're going to be doing today, simplifying expressions when there are variables in play. Now it's time for some examples. I did not number them, but I'm going to go row by row, and we're going to deal with them one at a time. You should have maybe a pen or a pencil or 2 different colors. That will be helpful. I'm going to use my blue and red. The first example, we just have 2 x's. My x's are going to be red, and because of that, we have just the plain old 2x. Now over here, I have a 2y plus a y. just like we did over here, we kind of pretended that there was a coefficient in front of these. So we could call it 1x, and then we add 1 and 1 and get 2. For this one, we can say that there is a 1 as a coefficient sitting next to the y. If we drew this out, we would have 2 y's representing this 2y, and then another y over here. So if we add the coefficients, we get 3y as our answer, and we see that there are actually 3 y's up there too. So now instead of 2 terms, we have 1. Instead of 2 terms, we have 1. Moving down to the second level, we have a string of x's and a string of y's. So here are my x's. I'm going to circle those, and I have 3 of them, so that means it's 3x. And then I have a string of y's. I have 3 of those, so I drag down an addition sign because I am needing to add these, and I have 3 y's. So instead of 6 terms, I now have 2. Yay, a lot simpler. For this one, we have coefficients next to each number. Notice here we just added like the coefficient was 1. Here we have a coefficient bigger than 1. So I'm going to circle my x's in red. I have a 2 and a 3, so that, if I add the coefficients, is 5x. And then my y's, we have 2y and 4y. When I add that together, I get 6y. Now I want you to make it a side note, literally like turn your book and like write in the margin. Adding variables like this is different than multiplying variables. So here's my little side note. If you are having an x plus an x plus an x, that is 3x like we saw over here. It's very different than multiplying the same number multiple times. That's what we did in the very beginning of the chapter. So this whole thing should be on the side of your notebook as a side note, literally. And when you add variables, you have to have a coefficient in the front, 3x. But when you multiply the same number, that's dealing with exponents. So these two things, be careful and make a note of that. Draw a cloud around it and star it and do something special because you have to make sure you have that straight. Okay, we're going to do a couple more. This one has a constant, and unfortunately we only have one constant. So we can't combine the constant, but we can combine the x's. So 8x and 2x is 10x, and we just have to bring down the 3. The last one is an example of the distributive property. So I'm going to take my 2 colors and I'm going to draw my 2 arrows from the 4 to the 2x. That means I'm going to multiply. Then I'm going to take my 4 and my y and I'm going to combine that as well. I'm going to add. Now because this is a variable, I can't figure out exactly what this is going to be simpler. But I can take my coefficients and multiply them. So I'm going to take this 4 and I'm going to multiply it by the 2 and call this 8x. If I wanted to show the picture, I would have 2 x's. Here's my 2 x's. But I'm going to repeat that 4 times. So 1, 2, 3, 4. How many x's do I now have? I have 8 of them. So that's why this is the way to simplify when you have a variable. You don't know what that x is, but you can take the number 2 and the 4 and multiply those together. For the 4y, I'm just going to get rid of the parenthesis so that I have 8x plus 4y as a simpler way of writing my original expression. Now I want you to put a star next to these words factor. This is going to be something slightly different that we're going to do, and I want you to pay special attention to how I'm doing this. And it's similar to the factoring out, but again, we have a variable in there. So just like when we were factoring out in the lesson before, we have to look at the coefficients and think what number is the greatest common factor between those. So I'm looking at 27 and 18. I could pick 3, but the biggest number is 9. So I'm going to think 9 times what gets me 27? 9 times 3 gets me 27. But because there is a variable in this expression, I need to drag it down because I don't know what it stands for. So that x just needs to be brought down next to the 3. Over on the other side, we are still going to be thinking what times 9 gets me 18, and that would be a 2. But there's a y sitting there, so we have to drag that down as well. I can simplify this by only writing 1 9. So I'm going to take my 9 and I'm going to put it on the outside of one set of parentheses. And now I'm going to take these smaller parentheses and combine them. So I'm going to take my 3x and my 2y and add them together inside one parenthesis. So that is how we factor when there's variables in play. Let's try another one. So look at the coefficients first. What number works with both of these coefficients? And that is 2. So I'm going to pull out a 2 and think to myself, what times 2 gets me to 30? It's 15. But remember, I have to drag this x along for the ride. Can't do anything but just drag it down. Then I'm going to do the same thing for the 4. I'm going to pull out a 2 and think what times 2 gets me 4, which is 2. And I have to drag that y down because I don't know what it stands for yet. Now let's simplify this by having 1, 2, and then a bigger set of parentheses, and I'm going to take that 15x and that 2y and put them together inside with an addition sign. One more thing to do. So the next problem is a word problem. I'm ending there, and I'm just going to give you the context before we dive in. If you've ever gone to a park or a museum, you have to pay to get in. So here's a picture of a national museum, and if you want to do anything extra, like go on a certain ride or go into a certain exhibit, you have to possibly pay a little bit more. So in this situation, we're going to be at a museum. You're going to have to pay to get in, but if you want to go to a special exhibit, you have to pay extra. So 3 friends will pay X for each admission to the museum. So to get in, you have to pay something. We don't know what it is. We're going to call it X. Plus $1 each to view the mummy exhibit. So that's the special thing they have to pay extra for. A 4th friend will want to go into the museum, going to pay for that admission, but they are not excited about the mummies, kind of freaks them out. They are not going to go and pay that extra $1. We have to write and simplify an expression that represents the total cost for all 4 people to go. So let's mark up our word problem. 3 friends, that's important, will pay X each, that means multiply, for admission, plus $1 each to view the mummy exhibit. A 4th friend will pay admission, which is X, but will not view the mummy exhibit. So there's these 2 words each. We have $1, we have X, and there's 3 of them that have that situation. So we know that 3 friends are going to have to pay admissions plus $1. So that 3 takes care of the 3 friends that have to do this, but we have a 4th friend. That 4th friend, the only thing he or she is doing is getting into the museum, which is adding an X. Now that we have our expression, now we have to simplify it. This is a distributive property example. So we're going to draw an arrow from the 3 to the x, that's 3x. There's another arrow we need to draw from the 3 to the 1, that is just 3. And then we have our x hanging out there as well. We have to just drag that down for now. Now we get to circle our x's because we can combine like terms. And when we do that, we have to add our coefficients. Pretend this is like a 1 coefficient next to it. And so our answer will be 4x plus 3. You go ahead and sign the bottom of this page. You are officially done with watching videos for Chapter 6. Congratulations. I'll see you tomorrow where we will practice simplifying expressions when there are variables involved. See you then. Bye.